Good day everyone, welcome to EC 101 Electronics Devices. So welcome to our first topic, Semiconductor Diode Part 1. So I hope you're excited to learn our first topic for today. So with this COVID-19 pandemic, it causes everyone to revisit global norms that has just been in backdrop, and technology have become more and more prevalent. What we are doing today is a vivid example. The online classes is a clear demonstration that technology plays a vital role in this period of pandemic. This would not be possible without the technology we are using. Without your computers, mouse, cell phones, tablets, or even the antennas, the radios, the modem, the microprocessor that is in your motherboard, in your PC. The electronic components play a crucial role. Without those switches, power management system, boost converters, buck boost regulators, and controllers, what we are doing today would not be possible. Here is the power management unit for micro-IC design of microprocessor integrated with energy harvesting and power management. So here is the layout view of the power management system. And here is the microscopic view of that IC of the power management. So the power management that I've designed is able to supply a 2.5 from a 1.2 volts of the battery. It able to cater or supply the sensor and transceiver requirement of 2.5 volts, and also it able to supply a 1.2 volts for the microprocessor. So even in that tiny little size, it is very tremendous design, I think. The outline of our topic for today is to discuss the ideal diode, the semiconductor materials, the energy levels, the extrinsic material of N-type and P-type materials. So for the learning objectives, we will discuss or introduce some basic of electronic devices and circuit theory. And first, to elaborate, first I will introduce to you the characteristic of an ideal diode device, then discuss the semiconductor materials, then number 3, discuss the energy levels for the electrons in its atomic structure, and lastly, the 4th, distinguish the difference between the extrinsic material N-type and P-type material. So let us continue our topic with ideal diode. So what is ideal diode? So ideal diode is the first electronic device that will be introduced. So it is the simplest of semiconductor device, but plays a very vital role in electronic system, having a characteristic that closely match of those simple switch. It will appear in a range of applications extending from simple to a very complex. So okay, I would like to reiterate. So diode is like a switch. So diode can act like a switch. It can be on or off. So the ideal diode is a two-terminal device. So the positive terminal is the anode here, and the negative terminal is the cathode. So mo na siya ayang two-terminal. So it has a symbol and characteristic, mo na yung symbol and characteristic as shown in figure 1A and B. So mo na yung symbol, mo na yung characteristic. So ideally, a diode will conduct a current in the direction defined by the arrow in the symbol. So ang kurente nato mo follow ani nga flow sa kurente. Otherwise, kung opposite ani nga arrow ang flow sa atong kurente, ang atong diode will act an open circuit. So, if ever, kibali, to illustrate more, let us draw a switch here. Like, this is a diode, ideal diode, that act like a switch. Kung kibali, ang atong kurente ni flow ana nga direction, same in figure 1a. So, ang atong switch will conduct. So, it will close, then, ang atong kurente mo flow ani nga direction. So, kung kibali, flow sa kurente ni follow sa figure 1a, then naay kurente, meaning short circuit. So, once opposite ang direction sa atong kurente, bali ni flow ang atong kurente atong direction, then ang atong switch or ang diode will act like an open circuit. So, unsa ang open circuit? Open circuit meaning walay kurente. Short circuit naay kurente. Considering the polarity of the applied voltage is consistent with that shown in figure 1a, pareho siya ani, kung ang cathode is naay positive, then ang anode na negative, then the portion of characteristic to be considered in figure 1b is the right of the vertical axis. So, kini ang atong i-consider. Then, otherwise, kung reverse voltage ang atong i-apply, meaning ang atong cathode na ay negative polarity, negative, then positive sa anode, then ang atong characteristic nga sundon is kini siya nga direction, to the left of the vertical axis. If the current, kung ang kurente nato, if the current of the diode has direction indicated sa figure 1a, then the portion of characteristic to be considered is above the horizontal axis. So, kini siya. So, above. So, while kung negative direction or opposite to the direction of figure 1a ang ni-follow sa atong kurente, then the portion to be considered is here. Okay? So, okay. For the majority of device characteristic that we will be discussing, the ordinate or the y-axis is the current axis, while the abscissa will be the voltage axis. So, one of the important parameters for the diode is the resistance at the point of region of operation. So, unsaan nato siya pag-solve? Just review. So, how to solve the resistance? So, just review your Ohm's law. V is equal to IR. So, solving for R, or the resistance, R is equal to voltage over the current. So, let us consider first in the conduction region, meaning ang voltahe nato ni follow sa figure 1a, then ang kurente po nato ni follow atong direction sa figure 1a, meaning ang atong, so from the Ohm's law, kung nato sa conduction region, meaning ni follow siya ani, as I've said, then ang atong voltage unsa man. So from this illustration, ang voltage nato at that condition is 0 volts. Then ang current nato is from any value above 0 or 0 upwards. So 0 voltage over any value, any positive value, makes a 0 resistance, 0 ohms, meaning short circuit. While if ever ang atong direction na aani opposite sa kini nga convention, ang atong cathode na negative, then ang atong anode na sa positive, then unsa ang atong voltahe o kurente to solve the resistance? So ang atong voltage is from any value of reverse potential. So, from 0 to negative potential. Over, unsa ang kurente nato? 0 ampere. So, meaning, any value or negative value or any, from 0 to any value, negative potential, over 0 ampere is equal to infinity. Meaning, open circuit. So, just remember, kung naata sa conduction region, ideal diode, ang resistance sa atong ideal diode, ideal diode is 0 ohm. While kung open circuit, ang resistance sa atong ideal diode is infinite, meaning open circuit. Also, try to remember, short circuit, meaning na ay kurente ni flow sa atong diode. Open circuit, walay kurente ni flow. In general, it is relatively simple to determine whether a diode is in the region of conduction or non-conduction simply by noting the direction of the current ID established by an applied voltage. For conventional flow, the resultant diode current has the same direction as the arrowhead of the diode symbol. Okay, mani ang flow sa kurente. So, the diode is in the operating conducting region as figure 1.3a here. Otherwise, kung opposite sa direction, then we have an open circuit. Then, as indicated earlier, the primary purpose of this section is to introduce the characteristic of ideal device for comparison with the characteristic of commercial variety. As we progress through the next few sections, keep the following questions in mind. Number 1, how close will the forward or on resistance of a practical diode compared with the desired 0 ohm level? So, i-compare nato ang katong ideal diode to the commercial one. So, is the reverse bias resistance sufficiently large to permit an open circuit approximation? Okay, let us try to answer that in the next following